The hook modifier allows us to control the deformation of a mesh's geometry using an external object. In some ways, hooks are like a cross between proportional editing and parenting, with one object, the hook, influencing part of a second object, the target. Proportional editing and parenting were covered in videos 23 and 27 respectively. We'll demonstrate how hooks works using a scaled-up and subdivided grid as the target, and a UV sphere as the hook. This is one of those occasions where we need to remember to apply the scaling, otherwise we won't get exactly the results we are expecting. First, we select the target object, in this case the grid. The next step is to choose the Modifiers page in the Properties editor. We click on Add Modifier, choose Deform, then Hook. In the panel that appears the Object field is where we select the object that is to be the hook. In this example, it's Sphere. There's also an option to pick the object directly from within the 3D viewport using the eyedropper. If we want to influence a specific vertex group, we'd select the group name in Vertex Group. That option can be ignored in this example. Strength sets the hook's influence on the selected vertices. A value of 0 means it has no effect on the vertices, while 1 assigns the maximum effect. We can leave this at its default setting for the moment. Now we enter Edit mode. This creates 4 new buttons in the Hook Modifier panel. Presently, we are only interested in Assign. Moving on, we now select the vertices that we want to be controlled by the hook object. And after doing this, we press that Assign button to finalize the link between the hook object and the vertices. Returning to Object mode, moving the sphere also causes the selected vertices to move. Notice, too, that the contents of the Hook Modifier panel has returned to its original state, with the 4 buttons disappearing. At the bottom of the panel is Fall Off. If we click here, we get an expanded set of parameters. Setting up a fall-off option adjusts how the vertices controlled by the hook react to the hook's movement. Let's start by looking at Radius. This is a measurement from the center of the selected vertices and determines how far around that point the selected vertices are affected by the hook's movement. Using the default value of 0, all selected vertices are affected equally. But if we change this value, then only vertices within the given radius are affected, and the further away they are from the center, the less they are affected. In other words, we have an fall-off based on radial distance. Note that the value given here has nothing to do with the distance between the hook and the target vertices. That distance has no effect on the movement of the vertices. Above radius is Type, and this determines the fall-off contour created. Most of these we've met before in the proportional editing video. No fall-off moves all selected vertices equally, irrespective of the radius setting. And Curve allows us to design our own fall-off profile in the panel that appears below. The last entry in the fall-off section is the Uniform Fall-Off checkbox. This is only useful if we forgot to apply scaling to the target object. Specifically, if we have not scaled equally in each dimension. To demonstrate, we'll create a second grid and, in the sidebar, scale it by 3 in the y direction and 5 in the x direction. After subdividing it, setting up a hook to the sphere, and using offset radius of 2, we can see that the profile created isn't quite right. However, all we need to do is check the Uniform Fall-Off box to correct the problem, since this fixes the profile by taking the non-uniform scaling into account. Going back to the Vertex Group field, We'll demonstrate this by first returning to our original grid and, in edit mode, selecting vertices around the four corners, setting these up as a vertex group called corners. Back in object mode, we'll add a hook modifier to the grid, make the sphere our hook, and select corners in the vertex group field. Now, moving the sphere only affects the vertices in the corners group. If we choose a radius value, this needs to be quite large since the origin for that value is the midpoint between all the vertices in the group. To the right of the vertex group field is the invert button. Pressing here inverts the vertex selection, choosing all of the vertices not in the specified vertex group. Returning to edit mode and that group of four buttons, we have already seen that the Assign button is used to assign the currently selected vertices to be those controlled by the hook. Should we return to edit mode and those vertices aren't selected, we can press the Select button, which will reselect those vertices previously assigned. The Recenter button changes the point in space, considered to be the center of the sphere of the hook's influence. In other words, this becomes the point from which the radius value is measured. Pressing the button moves that center to the location of the 3D cursor. Finally, the Reset button undoes the influence of the hook, returning the vertices to their original positions. However, the hook connection remains in place, and if we move the sphere, it will once again affect the selected vertices. It is possible to add other modifiers to our grid. For example, we might add the Subdivision Surface modifier to make the curves we create smoother. However, this must appear after the hook modifier, otherwise we get rather unexpected results. One last point is that the object used as the hook is often an empty. Since empties are not visible in the render, we see only the effects caused by the hook, but not the hook itself.